and welcome to the Drone Pilot Profits Q&A Monday. I'm Taylor Mitchum, and with me is Jon McBride. And tonight,
hey, how's it going?
And tonight we are going to talk about thermography. So if you can hear us, you can see us, put it in the comments below. And we'll go ahead. We'll wait a couple seconds for the comments to come in. There's a little bit of a delay with the software between when people comment on Facebook and by the time we see it over here in Be Live. So, hold on a second. Okay. All right, we got some viewers viewing in. Can y'all hear us? Can you see us?
This is going to sound terrible, but I'm going to watch this live.
Watch it first.
I'll turn the volume down so it's not so,
Yeah.
There, I got to turn it down. Okay, there we go.
I'm guessing everybody can hear us and see us because nobody's dropping off and nobody's saying they can't. Oh, Edward says it's perfect. So, okay. Let's go ahead and get started with Jon. So, Jon, how in the world did you get into thermography and UAVs?
Well, this is a passion that I've been doing for a very long time. 30 years I've been building radio control, and about 15 years ago I was involved in a company in which I did some engineering and creating flying helicopters and whatnot. That just went into owning and running a hobby shop for 10 years. And from there, it just kind of developed into the love of drones and UAS. And it was for me, it was an idea of being able to fly a drone and take pictures and video of my fellow RC guys that were at the RC field. So it wasn't really intended to do what it is today on how I got into it, but naturally, it's just kind of went that way. As far as thermography goes, a few years ago, I was approached by FLIR, who is a leading company in thermal imaging, and they were working on some possible projects to do the thermal imaging on a drone, and we're looking into a drone expert, if you will, to give them some feedback on that. So that's kind of where it started, the evolution of thermography as well. And I just kind of jumped in full force to learn as much as I could about it. So here we are.
Yeah, exactly. Here we are. Well, that's awesome. So we had some people that submitted questions beforehand, and I know you said you had a presentation you wanted to show to everybody. So let's go ahead and get started with that. And what in the world is thermography?
Okay. So probably one of the big thing is just understanding the basics of thermography. Thermography itself is by definition reading infrared detection of radiation. What that is molecules themselves will move rapidly, and when they move, we have a radiation, if you will. Thermography isn't only used in just doing search and rescue, as we have seen, or roof inspections, but you can do dating thermography to figure out how old something is. You can do radiometric detection, that is. And the portion of light in which we use for this, and the cameras are engineered for this specific portion, is about 9,000 to 14,000 nanometers. So that is in the infrared spectrum. And we pick up a portion of that that's a pretty wide range to be able to see those images or that video in thermography. So, in a general sense, the molecules will radiate. They're creating an amount of energy that is put out. Everything does that is above what we call absolute zero. And on absolute zero, anything that creates a certain portion of heat can be seen by this type of camera. So most of the times, thermographers, what they do is create thermograms or a report, a picture. And that picture can be then evaluated to look at whether or not something is hot or not, whether something is, we can then run that through an algorithm, if you will, and take that single one pixel and then define a temperature with a bunch of other parameters that usually come along with that. But some of the FLIR programs that we can use, I mean, such as FLIR tools, we can use this program to look at the actual report or generate those reports to people when it comes down to industry standards or numbers or requirements in which they want to use these deliverables, if you will. So some of the file formats that are commonly used in thermography are JPEG, JPEG-R, TIFF files, bitmap files. There's a lot of them, and then there's proprietary files. FLIR calls theirs a FLIR file format, so an FFF file. And when they use that FFF file, that's a proprietary file that can only be read by their tools, their tool system. So most of the handhelds that we normally see that people walk around with, and they take images, those handhelds usually are running FFF files. And this is fairly new, using thermal imagers on drones and then creating data, and as well as an end product or a deliverable. And that process has been taking some time. So to kind of figure out what people are needing, what the market is wanting, and how we can utilize the thermography system. So as far as the workflow right now, again, saying that there isn't a perfect path, there isn't anything that makes us, other than taking a single one picture and creating a report, there isn't, it's very difficult to try to stitch images together, both in JPEG and radiometric because of the way the camera works. So since that's a new way to create something, it hasn't really been done. Is that, so it hasn't been created. I mean, we're working on that right now, is in a way to create thermal maps and stuff like that. And we're talking a workflow that is easy for the typical drone user, not something that normally is being done in a major warehouse, a major control system of some sort. If they've got multiple computers and multiple programs and they create it themselves, they have their own writers. Now you got such programs like Drone Deploy or Pix4D, which are learning how to use these files and how to create reports and create pictures and things like that. So, but it's still fairly new. It's cutting edge. We're probably not going to see a real great workflow for the normal drone guy that just went out and bought a FLIR camera and generating these fantastic things that they've seen that other companies have spent millions doing. So we're trying to get that workflow down, trying to make it easy, trying to make it simple. So some of the things the questions that we do get, radiometric versus non-radiometric. Radiometric itself is the measuring of the radioactivity. So trying to quantify, as we had talked about, taking that one pixel and creating a temperature amount on what that one pixel is giving us. And by doing so, we can then create a generated report that can be used by any industry on that. But that does require a lot of other things in the radiometric side. Being able to do roof inspections or doing solar panel inspections, the client may require temperature off of those single one panels or temperature off of conduit or lines. And those things can be made of different things. So plastic or metal or shiny metal or bare metal, there's fiberglass. All of these things create a different emissivity value. And emissivity is kind of the big number in which can be changed, which really affects how the temperature readout kicks out in radiometric. So that's one of the factors, and there's probably 5 main factors that kind of depend on whether those camera settings are right to get a correct temperature value in a radiometric camera. So emissivity is one of them, reflective temperature is another, atmosphere, how far away you are, so distance away from the subject, and then the atmospheric around you, so the surroundings around you. So there's lots of factors that can kind of misinterpret what the camera sees as being a correct temperature or not. So it can be very confusing on exactly what to buy, what to get, what to purchase. But in a general sense, again, let's see, where we were. The benefits of it and trying to figure out what to buy and what to purchase is very hard. So the non-radiometric applications can be from search and fire, police, rescue, doing a simple roof inspection. And a roof inspection doesn't necessarily you need temperature, but you can see some differences in temperature because of saturation of fluid, like rain or whatever has gone underneath the barrier. So that cooling of that temperature, and we call this a relative temperature difference rather than an absolute temperature. So that relative temperature difference, you can see that on a roof. You can go to solar panels and you can clearly see that there's some differences in the way one solar panel looks versus another solar panel. And you can make an assumption that it's not working correctly, but you don't necessarily need a temperature. Hot spots, basically leaking windows. So if you have a window that might be leaking heat, you can see the heat escaping from the side and it heats up the outside of the building a little bit. That doesn't have to necessarily mean that I need temperature. So condensation, you can see that as well. In farming and agriculture, we can fly over a field. We can look at the dispersion of water that just been recently watered. We can see that there's portions that are cooler than warmer because of where the water is actually going and touching and saturating the dirt. So we can see whether or not we have clogged spigots or we have systems that aren't working. Lots of stuff in just AG and farming. The last little example of not having radiometric but still using this for an application is looking for livestock, like looking for cattle or cows, trying to find deer. Just recently we went out and did some hog hunting stuff, which is really fun, by the way, Taylor. That was really fun. So yeah, it wasn't really a real practical application, but it was really cool to do. You know, I just wanted to do a case study on that, but man, you could find and see the pigs quite easily. And obviously in Georgia, that's a big issue, and other states, that's a big issue. So you don't need radiometric to do those kinds of things, but when you do need radiometric, it's very important to understand how correct temperature is relative to getting the right numbers, you know, and kicking a report out that means something to make actionable or a deliverable that makes sense, you know, to that client. So again, some of the advantages of thermal in general, we're able to see things that normally we can't see with the normal camera. For one, people think, you know, hey, you know, is it only to be used at night, or no. You can use it during the day without any problems. That's not a problem, but sometimes when it gets really hot, you get a saturation of what we call a saturation of heat. So that saturation, the sun comes up and everything looks hot. So it's hard to discern the difference between a human being and them standing on hot pavement. You know, it's very hard to see. So obviously it's a lot easier to use at night than using during the day. A lot of thermal inspections that are done on rooftops are actually done at night rather than during the day. So there's some different things in questions that I had seen or had read about that. So some of the products, FLIR themselves, that's again who I kind of work with. There's a lot of products out there that FLIR makes that is pretty awesome as far as getting onto the UAS systems, adding them there, making them work. But for the most part, we'll start with what everybody likes, and I like personally is the XT. So the XT is capable of working on the Inspire, the M600, which is behind me, as long as you have the adapter, the M100. And this, you know, this being integrated completely into the bird is really awesome. So you've got an SD card on the side, and once this is connected, you've got all color palettes available. You have the ability to take pictures and do video at the same time, at least being able to run both of those functions while the bird is in the air. You have another thing called isotherms, search and rescue, and one of my good friends, Garrett Brill. Garrett uses the isotherm a lot in search and rescue applications because he can set the parameter of the camera to only kind of look at a certain temperature. It highlights that temperature. That isotherm is not available in any of the other cameras. It's kind of a specialized function of the XT. So the one thing about the XT is that it comes in various different lens profiles as well as resolution, which we'll talk a little bit here in a second. But there's a lot of different setups that you can do with this as far as what it's for, what you can do, how it'll be set up. So, and the file formats are very common file formats. They also created the TIFF file format on the XT because of the Pix4D. So Pix4D specifically likes to use or uses a TIFF file, and FLIR made that file for them. Other people can use that TIFF file, but that's who it was exclusively made for, was to create 3D models with TIFF data, which includes radiometric data. So other things that we have besides the XT, the standard XT does have a little spot meter. It is able to register or read temperature, but the XT Advanced Radiometric has we had just talked about dialing in some numbers like emissivity and reflective temperature and all these other nifty things that we can do to register a correct temperature. And that's where the Advanced Radiometric is what it was engineered for. So when people ask, which one do I need? I'm not sure. If you're going to do absolute temperature, and that's really important, buy the Advanced Radiometric. This would include possibly taking a thermography class, another something that we'll talk about here in a little bit later. But the other products that FLIR makes is the FLIR View Pro. And so the FLIR View Pro or the FLIR View, just the difference between the FLIR View and the FLIR View Pro is that the FLIR View has an SD card on the side, Bluetooth capable with an app. On the other side, I have the ability to run USB. That's where I get my video out. And then I have this little connector up at the top. It's a PWM connection in which I can change settings in the camera on the fly if I have that type of setup. Just so people know, in my office, I mean, this is my array of cameras, FLIR View cameras, and I have a couple that are on ships right now. But just right here, there's 12 different versions, which coincides with the 12 different versions of possible XTs, which also means that they are not, these here are not radiometric. So that even increases the amount of, hey, which one do I buy? You know, which can get very confusing. So, but the XT uses very similar, the FLIR View Pro as far as lens profiles, resolutions, capability. It's very similar, except you're just getting that full integration into the DJI ship when you're using the XT. Another one of the systems is called the Tau. The Tau, these all use a Tau core. So the core is actually a Tau core, but Taus can be configured to about 300 different configurations, and they're different lenses and again different resolutions and whatnot. They're not really easily adaptive into the UAS portion of it. These were initially created, and the core looked like a good idea to throw onto a drone, and people have experimented if they know what the heck they're doing, and turned out to be pretty cool stuff. That's kind of where it's moved forward, is from the Tau core to go, let's make something simpler for the drone guy. So, and that's just if you wanted to know a little bit about Tau cores, they can put 100mm lenses on them and see really far instead of 19mm lenses. But if you want a little bit more information, you know, of course, get a hold of me. And then lastly, for UAS stuff that FLIR makes is the Duo. So the Duo, that little guy is a GoPro form factor. We do have Bluetooth capability, press button record, SD card on the side. But the thing about this is that I can take 2 images at one time. Right when I click it, I have on the SD card have recorded an RGB image and a FLIR image at the same time. So that makes it a little bit easier because the XT doesn't work like that. These can be triggered with other cameras, but you kind of got to know what you're doing. And this kind of makes it an easy resolve for that. Only problem with this, which people complained a lot right at the get-go, is that this sensor is 160 DPI or resolution, has 160 resolution, and the detectable amounts aren't always well suited for FLIR at seeing somebody at 400 feet. So that's probably the only complaint that I've heard about this. But for $1,000 camera, and you can stick it on something and try it. That's probably a good one, and it includes an RGB, which is basically a 1080p camera. So other little things that do come up are, there's handheld units that you can buy. This is the C3 or the FLIR 1. This is about $600, I want to say, but it's kind of a specific little handheld unit. I'm sorry that we're using it for something else, so I don't have it. It's just the box. So, but it's a little handheld unit that you can walk around and do measurements. Also very low grade. You can use it for close shots and whatnot of certain things. And then the FLIR 1. And the FLIR 1 is a unit you can actually put on your phone, called MSX, and that mixes the two RGB as well as the thermal together to give definition around the thermal blobs. So some of those are some of the products that are out there that FLIR makes. Kind of getting right into it to answer. I mean, we're of course going to go through a lot of questions here, and I'm sure we are, but when you're getting started into this, there is no definite answer. A lot of the things just comes down to the budget. That's a huge one. And then your deliverable. So how much money do you have and what do you want to produce? So other factors are, what drone do you have? So if you have a drone in which, again, the XT can be utilized, there's great options for this. If you have a drone that doesn't have the capability of running an XT, we have the FLIR View Pro. Cost-wise, the XT is around $6,000 to start, and that's just a number, but that's $5,000 to $6,000, and then that's the baseline XT on a 336. Then it goes up to $10,000 for the 640, and then you can jump up $2,000 to buy their advanced radiometric. So you're looking at $7,500 to $8,000 for an advanced radiometric 336, and $12,000 to $14,000 on the other. So it gets fairly expensive, but having a higher resolution is definitely better, but it isn't always the end story of buying one of these thermal cameras. 336s do a really good job depending on what they're going to do. But if you have the budget, great, buy a 336. Equally, they're exactly the same with the FLIR View Pros. So they range from $1,500 to $3,000, and depending on whether they're radiometric or not, that cost has a really big thing in getting started. So our budget is kind of a big one. Do you need to do it in absolute or relative temperatures? Basically, do I need it radiometric or non-radiometric? So that will change the cost a little bit. When you buy, basically I have a thing here and it says, to buy or not to buy, that is the question. And we had discussed this earlier, Taylor, is what if people, should I go out and buy a camera just to buy one, or should I wait for my customers to start telling me that I want thermal? Can you do thermal? Is that a deliverable you can do? For me, I have found that most people that buy the camera that don't have the education on how it works are going to be dragging their feet on what to do with it. And then they think, oh, I spent a lot of money and now I've just blown up the money and my wife is mad at me and, she's whatever the case is, and they don't know what to do with their camera. So instead, I can help you create deliverables once you've thought to get into it, but you've got to figure out what line of work you want to do, So number one, starting with the budget. What is my budget? Number 2 is what drone do I have? Number 3 is what do I want to do with it? So those are 3 major questions that are always come up, and they're never definitive on, do this, do this, do this, and you'll be able to have a drone thermal company. No. When people do ask, it's good to come to an expert, Jon McBride, and ask, hey, what should I get, or would be the best thing to purchase or buy? It's so funny. I can see you in the background, smiling, Taylor. It's really funny. So
I'm trying to think. Oh gosh. Sorry.
So, and it's really important that you come to somebody that is either in the industry already or kind of working with thermal cameras right now. And it's no different than buying an RGB camera. I'm not a camera guy, to be honest with you. So I wouldn't even know, do I need a Canon 5D? Do I need a Sony A7? Do I need a GoPro? I mean, basically, GoPro, Sony, whatever. I don't know what to buy, so I need to ask somebody that's kind of been in it. So feel free to ask, and that helps with purchase. But from there, like I said, what deliverable should I do? The next one is should I take a thermography class? And that's probably been a very large question. Is it really important that I do that? Well, I believe it is if you're going to get into this thermography side of things. So who teaches these classes? Well, there's guys like me that will teach you familiarity with the camera, what to choose, what to work with, how to work with it. But there's other places that actually give you a certification. They give you a certificate. They give you a validation to the construction companies, to the inspection companies, to the others that mean something. And we all know, as we learned from Taylor's thing, her last one on construction, is that they're very specific about that. So if you have a certification of any sort, to include Part 107 or 33s or night waivers or whatever, that thermography certification means something. And additionally, you may have the drone with a thermal camera and the roofing company doesn't, but they have a thermographer that works at that company. And if you go walk out there with your cool, fancy $10,000 camera without any education on how to use it, you're going to look like a fool. I can promise you that once you get that data over to their thermographer and he asks you a few questions, you're going to go, what? I don't know what you're talking about. So we don't want to look like that. So certifications mean a lot in the construction/inspection industry. Certifications don't mean all that much specifically in thermal. I forgot to mention that the ITC, that's the Infrared Training Center, that's FLIR promoted or whatever. They give you this certification. And yes, it's expensive, but so is learning how to use, the correct programs and the correct stuff when you go to learn to be, any kind of other thing. You're going to take pictures, or I have no idea how to run Adobe or whatever, but I'm going to go take some classes to learn how to be better at it. And the fact that you can actually get a certification is really important. But another thing is that certification. I just mentioned night waiver. A lot of the work is done at night. That's probably something you can consider once you have your Part 107, is to actually get a night waiver. RMUS has a night waiver for the whole company, so anybody that's flying for RMUS has got that night waiver coverage. And I think pretty much that was the majority of the questions and kind of my talk, if you will. So we can open it up to any comments right now, unless you had any other questions yourself, Taylor.
No other questions for me. I think we went through all the submitted questions that we received beforehand, but we have gotten a couple of questions in the comments. This one's from Eric. Jon, we were discussing expert controls for the XT. Can you touch on that? Can you travel with your XT or other export controlled equipment outside of the US?
Good question, Eric. So in general, there are two what they call slow rate and fast rate that FLIR makes. 9 hertz version, so basically 9 frames per second, or per minute, per second, 9 frames per second, versus 30 hertz, 30 frames per second. Because these can be utilized or used in a heat-seeking application, there are regulations on this camera. We call that ITAR regulation, an ITAR regulation. So there are some equipment, some armed deals or whatever, some guns that are ITAR regulated, and the camera that is 30 hertz happens to be one of those. So exporting them, selling them, buying them, and putting them on eBay. So if you bought a camera from me and you decided you didn't want it anymore and you stuck it on eBay, and some guy in Iraq wants one, or a country in which is not an ITAR approved country, you could be held liable and go to prison for that. And they don't care the reason why. So with that being said, can you travel with the equipment? You can travel with ITAR regulated things, but you have to be very careful because any government can confiscate that without knowing that it's an actually ITAR regulated system. But just like an M16, you can travel with an M16, but the government might seize it and take it away. So if they take it away and then you are no longer in ownership of it, then you're still liable for it. So you have to check those regulations and check the countries in which you are okay to travel or okay to sell to or okay to buy from. So hopefully that answers your question, Derek. You know, as far as being able to travel, sell, and whatever. We are fully responsible for those once they leave the United States. And as a retailer, we are also very responsible to make sure we sell them to people that are not going to do anything bad with them. So
that's good. And actually, I had a question about training. I know we're taking a step back a little bit, but do you suggest that someone buys the camera? So if I decided that I'm serious, I'm going to get into thermals. Should I buy the camera first and then do training, or do training and then buy the camera?
Well, you had already mentioned that you had your camera. And
I'm asking for a friend.
I'm just saying you already have one, and most of the people are going to fall into your category. They've come up with the money to go ahead and buy one, and that's fine. I think it's kind of difficult to do training first if you're not knowing what you're trying to get into. You know what I mean? You can buy the camera and then learn your equipment, or you can do it the other way around. There really is no specific way to do that. But just my ITC training class was in Los Angeles. I live in Utah. It was $2,200 to take that class. I had to get there, and then stay in a hotel, and then pay $2,200 for the certification and get back. So all around, the whole thing cost me about $4,000 to get a certification of a level 1 thermographer. So that's a big investment by itself, is $4,000 or $2,200. Maybe there's one local, a little closer, but that's a big investment by itself, besides the cameras. So it's a serious step into the drone world, if you will. So.
All right. Next question. Any word on boson core integration for UAS? I don't know how to pronounce that. Any word on that, John?
The boson core. Of course, Jeff has to ask that question. So a little bit about the boson. It's not quite, doesn't have obviously it's very small. We know this. Very, very teeny. So the camera itself doesn't have a whole lot of circuitry and boards and connections and SD cards. So the boson, just buying one and putting it on a UAS is not easy per se. There has been some companies that have done it. Drone Expert has done this, and a couple other companies. But I will say that there is a good possibility that FLIR may be coming up with something, because the boson is a great little camera. So I can neither confirm nor deny that. And I may have to shoot you if I tell you.
Oh boy. Well, we're getting shot. We're going to prison. There's a lot of dangers on this Q&A. I'll tell you what.
Serious stuff.
I tell you what. So are you guys liking this so far? Are you liking what John's talking about? Do you like Q&A Mondays? Do you still like the format? Let me know in the comments below. We're going to get back to some more questions here. Let's go ahead and get a question from Lee. Is there a decent FLIR camera for the Phantom 4 Pro?
Okay, good question. No. So, and the best answer and the best way I could say this is that the Phantom series, when I did some modification to adding a FLIR View Pro to a Phantom, it was on a Phantom 2. because the Phantom 2 was easily modified, changed, I could create, make, do whatever I wanted to a Phantom 2. I could change the radio system, I could change the speed, I could do it a lot. This was easy to integrate into it. We could run this through the normal VTX. We could do a lot of neat things with this camera and the Phantom 2. Problem with the Phantom 3 and the Phantom 4s, it's not much different than full integration where the whole ship is, if you take things off and try to, like the camera, and remove a camera, it's like digging a camera out of an iPhone and expecting it to work later. It doesn't. When you take something out of it on the Phantom 3s and 4s, like removing the camera, you end up messing with all of the other sensors that are there. So it might be a little bit easier on a 3 or a 4. What you can do with a Phantom is still attach a FLIR view or a Duo and video transmit those back on the way we did the old Phantom 2s. You can do that. You can hard mount them. You can stick them on there. But trying to take the original cameras off and then trying to integrate these into them is difficult. I don't recommend it. And these aren't really heavy, but the Phantom wasn't really engineered to carry a whole lot. And so in addition to its already said camera and everything else. So it's very difficult to try to modify. You can do it. There's people that have done it as far as other companies, but their flight times drop drastically because you need to add not just the camera. You need the video transmitter. You need to power it somehow. You need to mount it somehow. And it's carrying the native stock camera as well. So I don't recommend it. It's not that it can't be done. It can, but there's some sacrifices there in order to make it work.
Good answer. Good answer. And so let's get some fan mail in the audience a little bit. So Tony says, yes, this is very informative. Keep this coming. Kelly says, yes, very interesting. Evan says, yes. Corey says, yes, this is great. I'm surprised nobody's commented on your hair yet, Jon. Maybe because you got it pulled back today.
I got it pulled back.
Oh, man. All right. We got a question from Ryan. He asks, basically, do you know if anyone is looking for fractures in the blades of wind turbines with thermal cameras?
I know that there is a company up in North Dakota run by a friend of mine, Louis Ferdinand, that basically is looking for fractures with an RGB camera. He has talked about wanting to do thermal, but there hasn't been. I don't think that I don't believe you couldn't see that there was a fracture or a crack, but it's how to create a report to do so. And he was working on a system to do that. So I'm quite sure that an anomaly can show up enough, but how close do you need to get to it, or you can't really zoom in very well with FLIR cameras. So it will depend on a couple of factors there. But can you see it? I would bet with an 80% chance that you could probably see a fracture in a wind turbine system, a blade, if you will. I'm sure you could, but.
Okay, another question from Devin. If you have if you have an RMUS mount, can you use that camera and just purchase the DJI gimbal so you can use it through the DJI Go app?
Okay, very good question, Devin. Basically what you're asking me is, I have a FLIR view and I want to make it into an XT. So I have this camera and I want to make it into this camera. Well, you can't. The software and hardware that's in this is actually different than what's here. And believe it or not, if we take a really close look at this camera, we can see, let's see how close I can get that. We can see two holes in the side in that silver band. And that actually is the same holes that line up on the XT where those screws go on that same silver band. The Tau core is being used on both of these, but it's what the camera has to be prepared for. So this portion of the silver band forward has to be prepared to be an XT, and everything from the silver band forward here has to be prepared to be a FLIR view. So you unfortunately cannot make this into this, and I hate to give you that bad answer, but that is the answer, unfortunately. And once you have bought the RMUS mount, and thank you for buying that. I'd love to hear a little bit more feedback on that, Devin, on how it's working for you. So once you do buy that, though, it is almost, you have to upgrade to the XT. It's impossible for FLIR to change one to the other just because of the hardware. It's expensive. The camera has to be recalibrated and everything else. So sorry, it's a no.
Sorry, Devin.
Let me add one thing to that, Taylor, though, is that there is the gimbal, like this gimbal back here. It's kind of hard to see, but that's the Raptor gimbal. Raptor is a FLIR, is an RMUS product that I basically kind of co-engineered with this, and it's made by Feiyutech, but we modify it so it can do a couple of other things. So if you want to, you can try to use this gimbal, but that again depends on what ship you want to put it on and whatnot. But
all right. So is there a thermal camera for the 3DR Solo? Says Tony. Asks Tony, excuse me.
There is a camera that you can buy, and it's not necessarily the camera. You're still buying a FLIR View Pro, but they did make, for the Solo, they did make a gimbal that was specific to that. I don't know if it's still available or not, but if you had the Solo, you could buy a gimbal that was made by 3DR, if you will, kind of integrates right to it, and then you just end up buying your FLIR View Pro and putting that on that gimbal. So there was a way to do that. I don't know if it's still available, but I did see that was something. OEM cams or something like that might have that, OEM cams. So to answer that question.
Okay, and is it easy to integrate the FLIR 2 Duo, or the FLIR Duo, excuse me, with the 3DR?
I've not seen one that, it's easy to integrate if you're going to fix mount it, but I haven't seen anyone that has made a gimbal for it yet. So as far as creating it for the FLIR View, that is available. Creating it for the Duo, not yet. At CES, I went ahead and helped them prepare a 3DR Solo to put the Duo on, but as far as gimbal controlled, I don't know of anyone that makes one yet that would be easy to integrate, if you want to call it that. Not yet.
Okay. Justin asks, what camera would you recommend for search and rescue and fire scenes? Needs to be versatile for both.
Okay, let me read that. What camera would you recommend for search and rescue and fire scenes? Again, a very broad question because it really depends on what drone you have, how much money you have, and what kind of deliverable you want to make. You've already defined the deliverable here, but how much money do you have? I always would suggest running an Inspire and an XT with a 13 millimeter 640 lens. That's usually what I recommend for the fire guys. We have a kit that has all of that together that runs a 336 resolution that's around $8,500. So that's the Inspire, a case, 6 batteries, an XT, and it can be used for both. It can be used for search and rescue, and it can be used for fire scenes. It really doesn't matter on the application for that. So just because of how easy it is to run an XT versus trying to get a FLIR View Pro to operate on a separate system, that's what I would recommend. And it's around $8,500 or so, $9,000 for that setup.
Okay, and Justin says I guess he's saying his budget is $20,000.
Oh yeah, so you can definitely step up to the Inspire One XT 640. So higher resolution and better. And the 640, if you get up into that 13 millimeters, so that gives you a broad enough view to be able to see, but keeps a small enough field of view to stay away. So 13 millimeter would work really good for that. Okay. 640 13.
Jeff asks, how does the Raptor integrate onto an Inspire?
Well, of course, Jeff has to ask that again. So we love Jeff. I love Jeff. He's the bomb. So I haven't really made a kit for that yet, Jeff. We run into the same problem of basically having it be an effective tool, even though it's a huge dollar difference, and we know this. But by adding the gimbal, VTX, everything else that needs to go on it, we're doing the same thing that I was just talking about, the P4P. We lose a substantial amount of flight time. Some people want to still put drop modules. When I do that, I have to remove a sensor in the back to get the center of gravity right. And there are, I didn't really talk about some of the other companies that make this adaptive unit to be able to try this, but there's the Gemini that has a twin system up front. And this adds on, and I didn't bring it with me, but this adds on another Taranis radio has to be functioned, and some people like that. They don't like that. So you have to run a black pearl screen that has an HDMI or some kind of an HDMI inputted screen that person that's running the gimbal, that other gimbal, has to operate. So it doesn't make it very clean. It is cheaper by a long run, but if you really want me to, I can engineer and create that. But it's been kind of in the back burner.
Gotcha. Alan asks, John, does the Inspire XT kit that you make for search and rescue include the dual camera setup, or I guess a dual camera setup?
So the Inspire XT search and rescue kit it has an X3 and it has a XT, but it doesn't have a dual setup. What I can do though is that we had just talked about having the RMUS mount on the back end. You can add an RGB camera on the back and run the XT on the front if you wanted to. But I can neither confirm nor deny that there might be something in the works that will help with this idea. So I'm just saying.
A thing that RMUS is working on, or something that Fluor is working on, or who's working on this secret thing?
It's kind of just hopefully it will help in the search and rescue area. It will help in the dual processing, so it will help. And it is an RMUS kind of a thing, but to get all the systems right and get everything working right, as well as, the Inspire has been a great bird. Everybody's got an Inspire. I'm still trying to work on things to make that work for that. So. Okay.
And Adrian says probably the M210 will work better because of the dual cameras. I would have to say I probably agree because it has that capability.
Yeah, that M210 is going to be a game changer, and I'll talk about this for just a minute. So you have the M200, the M210, and the M210 with RTK. The M200 is only a single imager. It's only going to run one camera. Basically, that system is going to be a Inspire on steroids. That's what that is going to be. So, will we call it a replacement for the Inspire, our old trusty, awesome Inspire? Not really, but it's definitely got some of the integration, if you will, for other applications to work really good. We've got the newer systems that the M210 are going to have, and the M210 or the M200 is also waterproof, if you will. It's waterproof. So being able to add that to the firefighters' workhorses of drones or anything like that will be very helpful. The 210 though, with twin imaging, that will also have some really good systems built in. Also, again, a little bit more expensive, $9,000 for that one, and but it's an industrial platform. It's not a toy. So,
and I think you answered Cliff's question a little bit. He asked if the M210s can be recording a single video file for both, I guess, via two payloads on there, or single for each payload, or dual. You get two or one if you have two things on it.
Yeah, I got it. It's good functionality. I mean, this will be a good question on the function. And honestly, I mean, I'm really wanting to get one of these in my hands as soon as possible. I don't know if the gimbals themselves are going to, be able to turn with each other or not. Will they be independent? Will the if you take one picture, will an SD card on this one record one image, and will it record this one image? How will they talk to each other? There's still some open questions on all of those parameters. So you know that I'm going to do my typical Jon McBride and tear that thing apart and fly the holy dog crap out of it and give you guys all those answers. So
awesome. We should do that live. I think we'll have a special Q&A Monday. Jon McBride tearing up an M210.
Yeah, absolutely. Happy.
That'd be awesome. Adrian, would the M210 RTK be even better than the M210?
Yes. And it's kind of a sidetrack question to the thermography, but I think there's, this is a good source. I mean, you're talking to the right guy as far as how they work, what they're going to do. So the 210 RTK, so we're going, Twiminger still. You can put a top-mounted camera, so I can take my XT and be able to flip this upside down, or the Z30 or whatever, and put it upside down so I can look at bridges and whatnot from underneath, and that is a huge thing. Well, if you're going to be flying next to a great big metal bridge, RTK is going to help you not lose your ship. So what RTK does specifically is gives you good flying precision when compass is erratic or giving you problems. So some of these guys that want you flying around their bridges or their high power tension lines or their substations or their dams or whatever, they're multi-million-dollar assets, and your drone is only a few $1,000s to them. So they don't want your drone hitting their multi-million-dollar system, and causing a problem. So RTK will help with this. So
awesome. And make sure you all get your comments in before the Q&A Monday is over, and let us know, do you like this? Do you want to see more? Let us know. Next question from Tony. For doing both roof and solar panel inspections, would the 13mm lens be best on a Pro 640? I'm guessing, 640 resolution.
Okay, so for doing roof and solar panel inspections, would a 13mm lens be best on the 640? I believe so. There is a video, and I will share that link later with you on a solar panel inspection array that we did, and it was great. It was a great big solar farm. Not quite something sitting on somebody's top of the roof, but we had about 430 acres, 220,000 panels. And I used the 640 9mm, 13mm, and 19mm, and kind of did a comparison between the two. So 13 in general does pretty good. 9mm can pretty much has a wider field of view, so it can see a lot more. But if you're to try to do mapping or imaging, the lens profile on that kind of bows the shot a little bit. So anyway, I do recommend a 13 to answer that question. It will be good for most general use on a 640 13. So
okay, and we got a question from the Catalan equipment work for daylight and nighttime thermography.
Yes, it does. So there is no worries about running a thermal camera during the day. It will still work the same way. But what we talk about is a little bit of thermal saturation. So thermal saturation is a hot black top with a person sitting on it. And that person can be very difficult to see. In a search and rescue type application, you can be working in the mountains. So I'm here in Utah, and I'm talking like 2 miles away from me is the foot of a huge mountain here. And so people get lost up there all the time. And if the sun has been beating down on the rocks all day and some guy happens to be sitting on a rock, he could be very difficult to see because there isn't what we call enough thermal delta, a change in temperature. It looks so similar. So It doesn't matter during the day. So your effectiveness tends to be a little bit better at night because the environment around it tends to cool down a little bit better, and you're able to see things a little bit better. So.
Gotcha. And I don't see any more questions in the comments. Last call for questions if you have questions for Jon. Lee says, thank you for the honest answer. Another reason to go get the Inspire. Love this presentation. Justin says, thanks for giving us some of your time. Evan says, I like Jon's setup. Let's look at some other fan mail here. Justin said again, thanks for the answers. Jeff, your best buddy Jeff said, Jon, you're the greatest.
Yeah.
The Catalyst said that we're a private group, so you can read us in on all the secrets. Also,
there we go. Yeah,
you can also bail me out of prison and treat my wounds when I get shot.
Right.
Alan said, thanks, Jon. You're the bomb. Adrian said, thanks, Jon. He said, thanks, Jon, again. And Corey left a long one. As I said, this is great, and I'll go back and watch what I missed. I'm trying to slowly get into the fire department side of it. And for my department, I'm already busy as all get out, so I'm taking my time to try and get this done right. And Corey, I'll definitely tell you, get in touch with Jon because he can help you in your fire department get the stuff that they need. Edward says, thank you. Kelly says, your expertise is amazing. Thanks for sharing this info with us. Edward said, this is way over my head, but that's okay, Edward. Baby steps, man. Ryan says, thank you. And Tony says, thanks, Taylor and Jon. And with that, we're going to go ahead and wrap it up because we don't have any more questions. If you all want to learn more about Jon and his company and what they do, I implore you to go to rmus.com. That's the right.
That's right.
Okay, good. And Jon's in all the groups, so you can tag him, Jon without an H, Jon McBride. He's in all the